Hey there. Today we're going to look at solving two-step algebraic equations. Now, two-step algebraic equations are just regular algebraic equations, except there's more than one step in order to solve them. The first example we're going to look at is 3x minus 5 equals 13. Now, this equation is going to have two steps to it because there's two different operations that are happening on the same side of x. One is that it's being subtracted by 5, and it's also being multiplied by 3. There's a multiplication sign here, but we never write it. Okay, so the main thing we have to do is we have to think about always our two big processes: opposite operations and balance. That's what allows us to solve just about any algebraic equation there is. Okay, so the first thing we need to do is we need to figure out what opposite operation we're going to use first. Now, we're going to first work with this minus 5. The reason for that is that algebra is like doing things backwards. You're like undoing something to figure out what x is and to get it by itself. And with regular order of operations, we always do addition and subtraction last. So in algebra, we do them first. So the first thing we have to do is get rid of this minus 5 by adding 5 to the left-hand side of the equation, and then doing the exact same thing on the right-hand side, also adding 5. What that does is it allows this minus 5 to cancel out, and we're left with, here on the right side of the equation, we're left with 18. And then on the left side of the equation, we're just left with that regular 3x. It just comes straight down. So now we have 3 times x equals 18. Now, since 3 times x equals 18, we always have to think opposite operations. The opposite of multiplying is dividing, so we're going to divide both sides of the equation by 3 in order to isolate x and get it by itself. So what we're left with is x equals whatever 18 divided by 3 is, which the number is 6. So there's our solution to our first example. What I'd like you to do now is to try the second example on your own by pressing pause, and then once you're ready, we're going to go ahead and solve it together. Okay, now that you tried that example on your own, we're going to solve this equation together. So again, since this x is on the right-hand side, you might think it's different than this first equation, but it's not. It's the exact same type of procedure. We first have to think about, okay, what's happening to x? Well, one is it's being multiplied by 2, and then in general it's being subtracted from this 8 here. So you can almost think of this multiplying by 2 as really multiplying by negative 2 here. So the first thing we have to do is always deal with the addition or subtraction part. So the 8, which is out here, we're being subtracted from, we have to think about, all right, what kind of 8 is that? I want to get rid of that 8. What kind of 8 is it? And the answer is it's a positive 8. Now the opposite of a positive 8 is a negative 8. So what we actually have to do is subtract 8 from both sides of the equation in order to get rid of that 8. And what comes straight down is this whole negative 2x. All right, we have 14 minus 8, 14 minus 8, that gives us 6. The next thing we have to do is we're trying to get rid of this negative 2 now. So x is being multiplied by negative 2. What's the opposite of multiplying by negative 2? Well, the answer is actually just dividing by negative 2. You don't change the sign at all when you're multiplying or dividing. So dividing by negative 2 on the left-hand side, that's going to cancel out. And on the right-hand side, it's going to change our answer around a little bit. Instead of having a positive number now, since we have a positive divided by a negative, since the signs are different, we're going to wind up with a negative answer. So 6 divided by 2 would normally be 3, but since one of them is negative, our final answer is going to wind up being negative 3. So x equals negative 3.